Hi, I'm JD, and in this lecture we're going to do an introduction to fractions. And here's a little preview. We're going to look at tools for fractions. That's tools for fractions of the fractions that we're going to go over today. We're going to look at multiplying fractions, simplifying fractions, dividing fractions, and the multiplication property of equality. We looked at the addition property of equality last week, and so this week we introduce the other property of equality to solve equations. All right, so let's get started. So here's some definitions. Prime and composite numbers. You could think of prime numbers as primary colors, so like 2, 3, and 5. And then composite numbers, which would be when you mix those prime numbers together. So if I mix 5 and 3, or 5 times 3, that's going to give me 15. It's going to give me green. If I have 2 and 3 and I multiply those, or I combine them, like paints, I get orange, or 6. So you could see that prime colors prime numbers are like primary colors. You mix them together to make secondary or even tertiary colors, which if you mix prime numbers together, you get composite numbers. Now, every number is either prime or composite, except for one. One is neither prime nor composite. Prime number is simply a number that only has two factors, itself and 1. And a composite number is one that is made up of prime numbers. So natural number, yeah, it's not prime, so it would not include 2. All right, here's some other things that are helpful. So we just looked at some definitions. Now let's look at divisibility tricks. Now, divisibility tricks are going to come up in this section. And what they are is basically, you don't have to divide the entire number. Use this trick, and it tells you that it's divisible by 2 or divisible by 3 or whatever. The divisibility trick for 2 is if it's even, that means it divides, 2 goes into it evenly, where you divide it by 2 and you don't get a remainder. Divisibility trick for 3, or to see if it's divisible by 3, is that you add up the digits, and if that sum is divisible by 3, that means the number is also divisible by 3. The divisibility trick for 4, it's not really a trick, but sometimes you can notice it. If the last 2 digits form a number that's divisible by 4, that means that the number that you have is also divisible by 4. And the last 2 digits would be the tens place and the ones place. If divisible by 5, it has a ones digit that is either 0 or 5. That tells you that the number is divisible by 5. Divisibility by 6 is if it follows the rules for 2 and 3. So that means if it's even and you add up all the digits and that sum is divisible by 3, that means since it fits both of those, it's going to be divisible by 6. Divisibility trick for 9, probably familiar somewhat with this if you're used to doing your 9 tables on your fingers. The sum of its digits is divisible by 9, the number. Now, if it's divisible by 10, the ones place, or the ones digit, is going to be 0. These divisibility tricks make it really easy when you're doing fractions and you have to divide quickly or things like that, you can also use the calculator, but where's the fun in that? All right, so let's look at our first example. We're listing out all the factors. So we're looking at 52. So a couple of factors would be 1 and itself. So 1 and 52. If I look at the number is even. So I know it's divisible by 2. Now 52, let's see, 52. The digits 5 plus 2 is 7, so it's not going to be divisible by 3. Perhaps divisible by 4. Yes. And notice that we have 13. You can also check to see if there's more factors by looking at the numbers that you found. So like if I look at 2 and 26, I know that another 2 can go into 26 evenly. So another 2 would come out. So that's how you would list out all the factors of a number. You can go on further, but notice that 13 is prime. So you can't take anything more out. So those are your factors: 1, 2, 4, 13, 26, and 52. Factor, by the way, is what's involved with multiplication. So you're going to see with these that factors come up when you have multiplication. So here it says find the prime factorization of 72. Well, if you want to do that, what you can do is do what's called a factor tree. So let's do a little factor tree on the side here. So we're going to take 72 and we're going to split it up. I know that 72 is divisible by 9 because the sum of the digits is 9, and 9 is divisible by 9, so I can do that. When I do that, I get 8 and 9. Now I'm going to focus on the 8 and split that up. I know 8 is even, so it's going to be divisible by 2. So 4 times 2 is giving me 8. Now let's go to the 9. So 9 is 3 times 3. Now on the ends of these branches, you want to get to the point where you have prime numbers, right? A number that's only divisible by itself and 1. So we have to go a little further with the 4. 4 would be 2 times 2. Now, to get your prime factorization, it's going to be the ends of these branches. So it's going to be that 2, 3, and that other 3. So it's all those branches. Again, this is a factorization. Factor involves multiplication. So to do the prime factorization, it would be 72 equals 2 times 2 times 2 times 3 times 3. It's all the ends of those branches. All right, so now let's do some divisibility tricks. I know we had been doing that already, but let's look at a big number so that we can see if we can find factors. So let's go in order. So let's look at 2. 2 is asking the question, is it even? And the answer is yes. So that means it's divisible by 2. And so I can take 2,370, divide that by 2, and it does it nicely. There's no remainder. So does the sum of the digits of 2,370, is that divisible by 3? Well, you add up the digits. So 2 plus 3 is 5 plus 7 is 12 plus 0. So that'd be 12. 12 is divisible by 3. So yes. Let's check those last two digits. So 70, is 70 divisible by 4? No. So the number is not divisible by 4. Is the ones digit, so now we're at 5, is the one digit of 2,370 a 0 or 5? Well, yes, it's a 0, so that means it is divisible by 5. Does the divisibility tricks for 2 and 3 work? So if I look at 2 and 3, that's a yes and a yes. So even, and then also the sum of the digits is divisible by 3. So the answer is yes. So that means that the number is also, that's divisible by 6. So is this number divisible by 9? Well, if I add up the digits, and I've done that before, then it adds up to 12. Well, 12 is not divisible by 9, so that means that the number is also not divisible by 9. So if you were to plug this in your calculator, you would get a number followed by a decimal, which means that there's a remainder. Is the ones digit of 2,370 a 0? This would be the divisibility trick for 10, and the answer is yes, which means that the number is divisible by 10. So these can be very helpful. All right, now we're going to find the GCF. GCF stands for the greatest common factor. And what you can do with these to find the GCF is to make the number into its prime factorization. If necessary, you can do a factor tree. Here, I'm not going to do a factor tree. 15 is 5 times 3 as prime factorization. 20 is 2 times 2 times 5. Now, the GCF is all of what they have in common. So they have a 5 in common, which means that the GCF is 5. Let's do a prime factorization of 24 and 40. 24. Now, here, you don't have to necessarily do a prime factorization. What you can do is find the common factor. If I look at 24 and 40, the largest common factor that goes into both those evenly would be 8. So they both have an 8 in common. And so that means that the GCF is 8. They also have a 2 in common, a 4 in common, but 8 is the largest one. Remember, GCF is the greatest common factor. Now, you could split it up, do a prime factorization. You would end up with 2 times 2 times 2, so that they would have 3 2's in common. So you would circle all of those, and you would multiply them. And 2 times 2 times 2 still gives you 8. Let's do a prime factorization of 12 and 13 so that we can find the GCF. Now, notice that they have nothing in common. But the GCF, you can always find a common factor. The smallest one that everyone has, every pair or 3 have, is a 1. So if you don't see anything that they have in common, the GCF is still 1. Because you can always take 1, divide it by 12 divided by 1, and then 13 divided by 1. You can always do that, and it divides evenly, meaning there's no remainder. All right, now let's get into fractions. Now here, fractions can be represented by shaded portions of a diagram. So one diagram or one whole. So the number of shaded parts, that looks like 7. And the number of total parts is 3 times 6, that would be 18. And so I can rewrite that as a fraction to represent the shaded compared to the whole would be 7/18. Now, if you have a number of wholes, they would be 1. So you always, what you do is you add up the pieces, and then you divide it by the total. And that total can be one rectangle or one circle. Typically, if you have multiple circles or multiple rectangles, the rectangle, just one of them, or one circle, represents the total number of parts that make up that fraction. All right, here's some fraction notation rules. Kind of went over this in the previous unit, but we'll go over it again because we're dealing with fractions here. So n divided by n, or a number divided by another number, is going to be 1. 0 divided by a number, which spells on, gives you 0. Now, if it's n divided by 0, that's where it's not defined. Sometimes you might see undefined, means the same thing. And since you have division, and division is kind of unique with ones and things like that. So if you divide a number by 1, you get that number back. So let's look at some examples. So if I look at 5 over 5, that's the same number over, well, it's the number over the same number. So you get 1. You have 0 divided by some number. That spells on, so that gives you 0. 7 divided by 0. That spells no, so that gives us undefined, or you say not equal to undefined, but is undefined. And if I look at the last one, 122 divided by 1, anything divided by 1 is that number. So the result is 122. All right, so now let's look at conversion of improper fraction and a mixed number. So how would you convert it from improper fraction to a mixed number? Well, what you do is you just divide. So 9 over 4, that's the numerator divided by the denominator. You can rewrite that as 9 divided by 4. Now, in long division, and depending upon where you learned division, it could look different. So we're taking 4 and we're seeing how many times it goes into 9. Well, it goes into it with an 8, which means I need 2. So 2 times 8, 2 times 4 gives me 8 with a remainder of 1. That remainder of 1 is going to be part of the mixed number. So you have 2, which is the number of whole parts, and then you have 1 over 4. 1 would be your remainder, and 4 would be what you're dividing by. So that's how you do that. You just divide, and whatever you're dividing it by, you take the remainder and put it over that. Now, how do you change a mixed number to an improper fraction? Well, you would multiply the whole part divided by what's in the denominator here. So 2 times 4, which is 8, plus that 1, which gives you 9. So that's what you're going to do there. So 2 times 4 plus 1 over 4. And then, so you get 9 fourths. That's how you do that. Now let's look at some examples. So with 41 over 6, you just divide. So 41 divided by 6 gives you 6 with a remainder of 5. I'm not going to work these out with long division. And so then you can rewrite that as 6 and 5 over 6. If I look at letter B, it's negative. You kind of want to ignore the negative when you're dividing until the end. So that would be 4 divided by 3. So that would be 4 with remainder of 2. And the negative you just put on front. So then you would, as a mixed number, you would write that as -4 and 2/3, right? You want to take that remainder and put it over what you're dividing it by. Now, if I look at -72/8, that is 72 divided by 8, that just gives me 9. And so my answer would just be -9. All right, this can be a little tricky. So you have 5 and 2/7. So you do 5 times 7 plus 2/7. Simplify that. 5 times 7 is 35 plus 2 is 37. So you get 37/7. Now with that next one, you have a negative in front. Ignore the negative. So you would do 10 times 7 plus 1/7. Put the negative up front, and then 10 times 7 plus 2. 10 times 7 is 70, plus 2 is 72. So you end up with -72/7. All right, now let's simplify. So simplify, what you're going to do is you're going to split up the numerator and denominator, and you can find the GCF. So the GCF of 12 and 18 would be 6. And so you split up the 12 as 2 times 6, and then the denominator, which is 18, 3 times 6. Now, we know that 6/6 with that fraction notation rule is just 1. So you'd simplify this, those would cancel the 6's, and you would end up with 2/3. If I look at 8 and 20, we're told to simplify that. 4 is what they have in common. So I can split up 8 as 4 times 2 and 20 as 4 times 5. And so those 4's would cancel, leaving me with 2/5. That last one, 603, divided by, or over 207. Just by looking at those and doing divisibility trick, I know that they're divisible by 9. So 9 goes into both of those, and I get 67/23. Now 23 is prime. I think 67 is too. So I'm pretty much done. Now, if you could go further, you would want to continue to simplify it until you can't simplify it no more. But yeah, that's it. So let's go to the next section. Multiplying and dividing of fractions. When you're multiplying fractions, you pretty much multiply across, numerator with numerator. Not pretty much, you do multiply across. Do not confuse that with cross multiplication. That's a little different. When you're multiplying fractions, you multiply across, numerator with numerator, denominator with denominator. Now, if possible, you can cancel first. And I would strongly suggest this because it's going to make the multiplication easier because you're going to have smaller numbers. And you can either do this with either within the same fraction or diagonally. Now, the division of fractions, what you do is you keep it, change it, flip it. And then you follow the same steps as multiplication. Now, if need to, if you have mixed numbers, you would convert them to improper fractions first. The mixed number, like 4 and 1/2, technically it's the same as 4 plus 1/2, so it makes things a little different. So you want to convert it to the improper fraction first. That's the reasoning behind that. All right, so let's look at an example. First, I would rewrite it as fractions. So 40 over 7 times 7/8. I would simplify them, the 40 and the 8. 8 goes into both of those. 8 goes into 45 times. 8 goes into 8 once. So that leaves me with 5 over 1 times 7 over 1. Multiply across, I get 35 over 1. And here I can simplify it because I'm just dividing it by 1. It would just be 35. And that's my answer. All right, let's look at a definition. This comes up, reciprocals comes up when it's going to come up in college algebra. It comes up here because keep it, change it, flip it. Division of fractions is the same as multiplying by the reciprocal. So when you multiply the two numbers together or two fractions together, you're going to get 1. That's what product means. 0 does not have a reciprocal. And to find it, you just flip the numerator and the denominator. If it's negative, it stays negative. Now, when I'm thinking about it, this definition also comes up with the multiplication property of equality. So let's look at example number 10. The first thing that you want to do is you want to keep it, change it, flip it. KCF. I would write that right underneath, like what I did. And then keep it, so 2/5 stays the same. Change it, division changes to multiplication, and then you flip it, so 3/4 becomes 4/3. Looks like you can't simplify it, so you just multiply across. So 2 times 4 is 8, 5 times 3 is 15, and you can't simplify that, so you're done. All right, let's look at another example. Sometimes this is called a complex fraction because you have a fraction over another fraction. But you still do KCF. You would keep the top the same. Now, the fraction bar is acting like division here. So then you would change that fraction bar to multiplication, and then you would flip 14 over 25, or find its reciprocal. So that would be 7/15 times 25 over 14. You can see that I kept it, changed it, flipped it. Then you can simplify where possible. I can simplify the 7 and the 14. 7 goes into both of those. And then 15 and 25, 5 goes into both of those. So 7 goes into 7 once. 14 goes into 7 twice. Now with the 5s, the 15s, and the 15 and 25, 5 goes into 15 3 times, and 5 goes into 25 5 times. So I have 1/3 times 5/5, multiply 5/2, I should say 5/2, and then you would just multiply that across. So 1 times 5 is 5, and then 3 times 2 is 6. That's it. All right, so now let's look at the multiplication property of equality. So just like the addition property of equality, you're doing the opposite. So if you see multiplication, you want to do division. Or what you can do, if you see multiplication, you can multiply by the reciprocal. So whatever you do one side, you do to the other side. We've seen that before. And then divide both sides or multiply both sides by the reciprocal. So let's look at a couple examples of this. So I'm going to rewrite the equation so it's more centered. 7x equals negative 28. So I'm going to divide, because I have 7 times x, 7 times x. So the opposite of multiplication would be division. So I would divide both sides by 7. Now, when I divide both sides by 7, the 7's cancel. That actually leaves me with 1x. And then on the other side, negative 28 divided by 7 is negative 4. 1 times x is just x. So there's my answer. X equals negative 4. Let's look at another example. I'm going to center this a little bit. Now notice what's in front of the x is a negative 2/3. You have a fraction in front of there. If you divide both sides by a fraction, it's going to be really complicated. But what you can do instead is you can multiply both sides by the reciprocal. So the reciprocal of negative 2/3, you just flip it. So you would multiply both sides by a negative 3/2. And remember, whatever you do on one side, you do to the other side. Negative 3/2 times negative 2/3, that's just going to give you 1. And then on the other side, the 2, because you can rewrite 18 as 18 over 1, the 2 cancels out with the 18, leaving you with 9. So I have 9 times negative 3 on that other side. And so 1 times x is just x, and then 9 times negative 3 would be negative 27. Done. All right, so let's review. So we went over tools for fractions. We went over divisibility tricks, finding factors, GCF. We went over some of the fraction rules. So like a number divided by a number is 1. When it spells on, that is 0 divided by a number. That means it's equal to 0. When it spells no, a number divided by 0, that's when it's undefined. And any number divided by 1 gives you that any number. We looked at improper fractions and mixed numbers, how to convert them between the two. We looked at simplifying fractions. When simplifying fractions, you want to find what's in common with the numerator and the denominator, split them up, and then cancel out what they have in common. And when you're canceling things out, if everything cancels, you're left with ones. So just keep that in mind when you're canceling things. With multiplication, we saw that you can simplify it first. And then if you simplify it first, cancel things out first, and then just multiply across, makes it easy. Dividing fractions, we learned keep it, change it, flip it. That keep it, change it, flip it, then changed it from division to multiplication. And then the multiplication property of equality, when you have x and that's being multiplied by something, you would divide both sides, or in cases of fractions, it's easier to multiply both sides by the reciprocal.
That concludes this video. Please like, share, and subscribe. And if you have any questions, put them in the comments below. Thank you, and I hope you have a wonderful week.